The choice to use relational databases locked in a specific approach, one based on total ordering. Total ordering means that every piece of data must be related to another in a strict sequence, even if there's no real-world reason to impose that relationship. Forcing all data into a single total order creates unnecessary complexity, leading to slower performance and inefficient systems that are rigid and costly. This is where DADA X takes a fundamentally different path. Instead of relying on total order, DADA X uses posets, or partially ordered sets, which allows us to only define relationships where they actually exist. This means that events or data points that happen independently don't need to be forced into an arbitrary sequence. We can model causal relationships as they naturally occur, which gives us a system that's more flexible, more elegant, and far more efficient. In the world of event computation, understanding how events relate to each other is crucial. Let's discuss these two ways of organizing events, total order and partial order. On the left, we have total order. It's like a strict timeline. A always before B, B before C, and so on. Simple, but not always realistic. But real-world events are often more complex. That's where partial orders, or posets, come in. Look at the diagram on the right. Here we still have some clear relationships. A comes before both B and C, and both B and C come before D. But notice how B and C aren't connected. This means they're independent or concurrent events. They're free to happen in any order or even at the same time, just like in real life where you might check your email while having coffee. DADA X can model both causal dependencies, like A leading to B and C, and concurrent events, like B and C happening independently. Think of traditional systems as trying to fit everything into a single straight line, forcing everything into a strict order, even when events aren't directly related. DADA X, on the other hand, sees events as part of a network of relationships where only the relevant connections are tracked. This flexibility is why posets are so valuable. This makes it far more efficient and able to adapt in real time. In real-world applications, this could be a workflow where some tasks depend on others, but some can happen in parallel. Or in a distributed system, where some events must happen in a specific order, but others can occur simultaneously across different nodes.